Okay, so let's try and solve this sample problem. Two plates of opposing charges are separated at a distance of 10 centimeter. So I have these two plates right here, this blue one and a red one. This blue one is about 100, is a positive charge, and this red one right here is a negative charge plate. The potential at positive plate is 100 volts, while the potential at negative plate is 0 volts. What is the magnitude and direction of the electric field? And what is the potential at 2 centimeter, 4 centimeter, 6 centimeters, and 8 centimeter? So let's write our given first. So first we are given the two plates, and these two plates are separated at a distance of 10 centimeter, or that is equals to 1 or 0.1 meter. The potential at the positive plate is 100, while the potential at the negative plate is 0. What that means is that the delta volts, or the change in the potential or electric potential between these two, is actually 100 volts, meaning that's 0 minus 100, or 100 minus 0. The potential at the positive is 100, the potential at negative is 0. So what is being asked is, first, what is the magnitude of the electric field? So earlier we discussed that using the electric potential, we can actually find the electric field. Moreover, now it's asking what would be the potential at 2 centimeter, the potential at 4 centimeter, 6 centimeters, and 8 centimeters. So how are we going to solve this? Well, first understand that our formula for this equation would be, for E is equals to change in electric potential divided by the distance. We've discussed this just previously, just earlier, right? So if we are going to solve this solution, the electric field between these two plates would be the difference in their potential, or electric potential, which is delta V, which is 100 volts, divided by the distance between the two charge, which is 10 centimeters, or 0.1 meter. So your E here is actually about 1000 volts per meter. Next, we are going to solve for the V, or the electric potential, at 2 centimeter. How are we going to solve this? Well, basically we just have to solve for V right here. So basically from 0, let's have this as our 0 centimeters to 2 centimeters to 4 centimeters, 6 centimeters, 8 centimeters, and 10 centimeters. So in order for us to solve this, basically what we want to do is we have to use the same equation and rearrange the equation, which is delta V is equals to ET. And using that V as our, which is basically V initial minus V final. So what we're going to do is we can take, this is also just 2 centimeters, 4 centimeters, 6 centimeters, 8 centimeters. It doesn't really matter, you can choose, but what we're going to do to make our life easier, we'll just choose 0 volts as our beginning. So that is just 0, we're just going to take our V minus 0 volts is equals to ED. So what that means is we're going to take our 1000 volts per meter, which we solved earlier, multiplied by D, on this time we are looking for 2 centimeters, so that's 0.02 meters. So since this is just 0, we just left with our V. Our V at 2 centimeters is just equals to 20 volts. The same thing volts for our 4 centimeter. So that would be 4 minus 0 volts. We'll just taking 0 volts. So ED, so our V, so just remove the 0 volts. So that's 1000 volts per meter multiplied by 0.04 meters. So cancel the 4 meters and you would get 40 volts. What is the volts at 6 centimeters? So the same thing, which is 1000 volts per meter multiplied by 0.06 meters, and that will give you 60 volts. And lastly, what is the potential at 8 centimeters? So that's 1000 volts per meter multiplied by 0.08 meters, and that is equals to 80 volts. So that's how you are going to solve for this type of problem. Now let's try this next problem. A conducting sphere of radius 3.25 centimeters. So let's draw our sphere. So this is sphere. Right, so this is our sphere and it has a radius of 3.25 centimeter and has a total charge of Q 4.50 times 10 raised to negative 9 coulombs distributed uniformly on its surface. So this Q is only found on the surface. And that makes sense because if you guys remember conducting versus insulating spheres, conducting spheres has their charges only on the surface. So the charges are all found on the surface. So these are your given. So what it's asking, first find the potential on the surface. So we are going to find the potential on the surface. B, we are going to find the potential inside. And C, lastly, what would be the potential at 5 centimeters from the center of our sphere? Well, we are going to go back to our formula for potential, which is V is equals to K Q over R. So if we are going to solve for this solution, firstly, we just have to, for our surface, so that is just basically K, which is 9 times 10 raised to 9 Newton meter squared per coulomb squared multiplied by your Q, which in this case, since this is the surface, so we are looking at the whole charge along the whole surface. So that's 4.50 times 10 raised to negative 9 coulombs divided by your R, which in this situation your R is distance of 3.25 centimeters or about 3.25 times 10 raised to negative 2 meters. So one of the meters gets cancelled, Q here gets cancelled. So the potential in this part is actually just about 1246 volts. Okay, so that is your potential on your surface. Next, let's find the potential inside. The potential inside is how much as potential that you can find inside, the answer is simply 0 because there would be no work done. The reason is because this is a conducting sphere, there are no charges inside. So the charge inside is basically 0. And anything multiplied by 0 at this point is just 0. So the potential inside is 0. And lastly, what is the potential at 5 centimeter from the center? Well, if I'm going to draw with an R of 5 centimeter, so if I'm going to draw something like that, you will notice that your charge will be found inside, right? So that is still taking the same equation. So 9 times 10 raised to 9 Newton meter squared per coulomb squared, multiplied by still 450, but this time it is inside, times 10 raised to negative 9 coulombs, divided by your distance now is 5 times 10 raised to negative 2 meters. This gets cancelled, coulombs, you have your coulombs cancelled, and that is actually equal to 810 volts. Okay, so I hope you guys get it. If you guys have any question regarding this sample problem, please do not hesitate to message me. Thank you so much, guys, and may you guys have a great day.